Space paths of laser radiation emanate, cognizant signs all through the cosmos. What's more, we as people are not, tragically, adequately brilliant to figure out. Andromeda, our cosmic neighbor, can be seen in our skies without a telescope, which is intriguing. Anyway, things have gone from intriguing to upsetting and disturbing. Makaku has uncovered that the James Webb Space Telescope has received disturbing signs coming from Andromeda. What's more, these signs end up being much more perilous than could have ever been expected. Join us on this excursion to discover the reality behind these disturbing signs and how the future could be far more alarming than we ever imagined. Andromeda is an inestimable giant with captivating qualities that distinguish it in the vast universe. Otherwise called M31, it is the largest galaxy in our area with a great breadth of roughly 220,000 light-years, a genuine heavenly wonder concerning its infinite extent. Albeit the Andromeda galaxy lies at a significant distance from Earth, around 2.5 million light-years away, its position in the universe places it beyond the confines of our cosmic neighborhood. In spite of its size, which may be alarming, it is also captivating to observe its structure. Andromeda shares a similar foundational layout to our own Milky Way galaxy, with a barred spiral design. This feature is highlighted by a central bulge of matter surrounding a flat disk containing stars, gas, and cosmic dust. Its balanced structure demonstrates the noteworthy complexity of this world. In terms of its stellar population, Andromeda is home to an unprecedented 1 trillion stars, far surpassing the number of stars in our own Milky Way, which is around 250 billion stars. This explains why it is so apparent from Earth, since its splendor is considerably greater. Anyway, the greatness and radiance of a galaxy are not the only fascinating attributes. Open space conceals quite a large number of mysteries, and every galaxy has unique and amazing quirks. At the center of the Andromeda galaxy, a concentrated bulge of matter stands out in the spiral structure of the universe, illuminating a distinctive appearance. The central bulge is believed to contain a high concentration of stars influenced by the gravitational pull of the galaxy itself. Considering that the galaxy has an abundance of stars, it is not surprising that a proportion of them cluster together to form this bulge. Additionally, there are more than 400 globular clusters scattered throughout the entire galaxy, which are spherical collections of stars bound together by gravity. So, in spite of being a massive cosmic giant, the Andromeda galaxy is not alone in space. It has an escort of at least 14 known satellite galaxies orbiting around it, forming a fascinating cosmic family. The interactions between the main galaxy and its satellites play a significant role in the formation of their respective structures and evolution, contributing to the rich variety of cosmic phenomena in the Andromeda system. The presence of a ring of dwarf galaxies surrounding Andromeda has been discovered. These dwarf galaxies are relatively small and faint compared to Andromeda and the Milky Way. The finding of this ring suggests the gravitational interaction between Andromeda and these dwarf galaxies, showing that the dwarf galaxies are under the gravitational influence of Andromeda, likely due to the massive gravitational force of this galaxy. The ring of dwarf galaxies is a subject of active research, as the exact nature of this relationship and the mechanisms that led to the formation of this ring are still under study and examination by scientists. To advance our understanding of galaxies, dark energy, and star formation, including the Andromeda galaxy, two powerful instruments are being utilized: the James Webb Space Telescope and the Dark Energy Spectroscopic Instrument. These instruments play a vital role in the study and investigation of cosmic phenomena, allowing the mysteries surrounding the Andromeda galaxy and its stellar environment to be examined with more significant detail and precision. The James Webb Space Telescope is regarded as the most powerful telescope ever constructed and is designed primarily to observe the universe in the infrared spectrum of the electromagnetic spectrum. This feature allows it to study the first galaxies forming in the early universe by detecting the faint light emitted by these distant galaxies. The James Webb Space Telescope aims to provide significant insights into the formation and evolution of galaxies, including the Andromeda galaxy. Its observations will contribute to our understanding of the processes that have shaped the universe over time. On the other hand, the Dark Energy Spectroscopic Instrument, or DESI for short, is an instrument specifically designed to study dark energy in galaxies. DESI uses optical spectroscopy, which involves analyzing galaxy light into its distinct wavelengths to analyze the spectra of millions of galaxies. Through this extensive spectroscopic survey, astronomers can measure the distances to galaxies and obtain information about their properties, such as their chemical composition, formation history, and motion. DESI's examination of the distribution and motion of galaxies sheds light on the enigmatic nature of dark energy, a mysterious force that drives the accelerating expansion of the universe. In the specific context of the Andromeda Galaxy, DESI's observations have provided intriguing insights into the transient history of stars within it. By analyzing the spectra of individual stars, DESI can reveal information about their chemical composition and origins. This allows astronomers to trace the history of star formation and follow the evolution of stars within Andromeda. By learning more about stellar migration patterns, scientists gain a better understanding of the formation and evolution of the galaxy, as well as its interactions with neighboring galaxies. Moreover, recent studies have provided undeniable evidence for the presence of a stellar halo in the Andromeda Galaxy that bears similarities to that of our own Milky Way. Why galaxy? This discovery has illuminated the dynamic nature of galaxies and the intricate interactions between them. Observations and simulations suggest that a significant number of stars found in the outer regions of Andromeda's stellar halo have migrated from small satellite galaxies that were gravitationally captured by Andromeda over time. Severed dwarf galaxies merged with the Andromeda Galaxy, bringing their stellar populations with them. This process of cosmic cannibalism is known as galactic accretion or merger. Galactic mergers are believed to be common in the universe and shape the structures and characteristics of galaxies, including Andromeda. The presence of stars from other galaxies resulting from interactions and mergers with smaller companion galaxies helps researchers understand the kinematics and distribution of stars in the stellar halos of galaxies like Andromeda and the Milky Way. By studying the populations of stars in these stellar halos, astronomers can trace the history of galactic mergers and interactions that have shaped these galaxies over billions of years. The stellar halo contains stars that have been absorbed from smaller satellite galaxies or star clusters, and their properties can provide valuable information about the history of galaxy mergers and assembly. This galactic merger process has been a key factor in the evolution and formation of galaxies, such as Andromeda, and has contributed to the diversity of features and structures seen in them. Through detailed observations and programmatic insights, scientists can analyze the chemical composition, age, and motion of the stars that form the stellar halos. These data allow them to reconstruct the timeline of galactic mergers, identifying the progenitor galaxies that contributed to stellar populations and understanding the physical processes involved in such mergers. This approach is of utmost importance since, if this gigantic galaxy will ever come into contact with our own, it would be vital to be prepared with all available data. The Andromeda Galaxy, otherwise known as Messier 31 M31, stands as a cosmic wonder within the universe, captivating astronomers and enthusiasts alike with its sheer size, structure, and fascinating characteristics. Situated around 2.5 million light-years from Earth, Andromeda is not only the closest spiral galaxy to our own Milky Way but also one of the largest galaxies within the local group, a cluster of galaxies that includes both Andromeda and the Milky Way. Spanning an impressive width of around 220,000 light-years, Andromeda boasts a grandeur that rivals our own galaxy. Its appearance in the night sky, visible as a faint elongated patch of light without the aid of a telescope, has intrigued astronomers for centuries. The galaxy's spiral structure, reminiscent of our Milky Way, reveals a central bulge surrounded by a flat disk containing stars, gas, and cosmic dust. This symmetrical design highlights the complex interplay of gravitational forces and stellar dynamics that shape galactic structures. At the heart of Andromeda lies a dense central bulge, a concentrated region of stars and interstellar matter that forms the galaxy's core. This bulge is believed to house a high concentration of older stars, which likely formed early in the galaxy's history. Surrounding this central bulge are spiral arms that extend outward from the core, adorned with paths of dust and gas, interspersed with luminous regions of young, hot stars. These arms, where active star formation occurs, contribute to the galaxy's overall brilliance and apparent luminosity. Andromeda's stellar population is staggering, estimated to include over 1 trillion stars in total, surpassing the roughly 250 billion stars found within the Milky Way. This abundance of stars distributed across its vast expanse adds to Andromeda's brightness and visibility from Earth. Observations and analyses of Andromeda's stellar composition provide valuable insights into the processes of star formation, evolution, and the life cycle of galaxies. In addition to its stellar richness, Andromeda hosts a myriad of other celestial objects within its domain. Over 400 globular clusters, compact spherical collections of stars bound together by gravity, are scattered throughout the galaxy. These clusters serve as repositories of ancient stars, offering astronomers a glimpse into the galaxy's early history and formation. Their distribution and characteristics offer clues about the environmental conditions and gravitational influences shaping Andromeda over billions of years. Beyond its stellar constituents, Andromeda exhibits a dynamic relationship with its satellite galaxies and neighboring cosmic structures. The galaxy is orbited by at least 14 known dwarf galaxies, smaller companions that gravitationally interact with Andromeda. These satellite galaxies,